Hey, what's up everybody? This is the Helpful Hacker, and today we're going to be going over the networking concepts room from TryHackMe. So we'll jump right in and get started with task number 1, the introduction. So basically it's just going to tell you a bit about the room, and it's going to tell you about the networking module that TryHackMe just put out, and it has 4 rooms in it. These are the 4. So keep that in mind, because as I'm going through this room I might not go into great detail on certain things, or I might say, we'll talk about that later in a different room, and chances are it's because whatever that is, it's hit in more detail in one of these rooms. So keep that in mind as we go through this room. And then down here we can check out our learning objectives, and then same thing up here, you got to look at the room prereqs. So basically you should have some idea about networking. If you have no idea about networking, or all of this sounds super unfamiliar to you, then you should check out the pre-security pathway and make your way through that first, and then come here, and hopefully these concepts will be a bit easier to understand. So read through all that. Once you have, mark complete. And with that, you're done with task number 1. Now it's on to task number 2, the OSI model. So the OSI model stands for Open Systems Interconnection Model, and basically it's a conceptual model, which just means it's like the ideal model that, hypothetically, theoretically, this would be the ideal way that everything would work when it comes to, communicating on a network. And so that's what this is. So this isn't in actuality exactly how things work. It's close. What we use in reality is modeled after this, but this is just the ideal model. But you still have to know it, because a lot of times people will refer to different layers on this model. They may just use the word like the application layer, or they may just refer to layer 7, and you're expected to have an idea of what that means. So read through all this, and then we'll talk about each layer. So layer 1, the physical layer, this is literally, think of all the physical things. So, whether that's wires, whether that's, Wi-Fi, basically any medium that signals can travel through, right? So that's electrical, optical, or wireless. And then think of binary, the ones and zeros that are actually being sent across the wire. So all the physical stuff, pretty straightforward. That's layer 1, the physical layer. Layer 2 is the data link layer. So the physical layer defined how we transmit our signal, or the medium that we use to do that. The layer 2, or data link layer, basically determines how 2 nodes or 2 hosts on a network communicate. And when you think of this layer, because that's kind of a mouthful, read through all this, but what I really want you to think about when you think about layer 2 is think about a MAC address, which stands for Media Access Control Address. And what this is it's an address. It looks like this number down here. The first half represents the vendor who actually built the network interface card, and then the second half is the actual unique address of the network interface. And usually this is lasered in to your network interface card, which is inside your computer. It's a piece of hardware inside your computer that actually allows you to connect to a network and be identifiable based on this MAC address. So again, that's a lot. If it seems like a lot, you can always check out the pre-security pathway, or you can Google MAC addresses and learn a bit more. I'm not going to go into too much detail here, because they do a good job if you just read through all of this. Down here, they give you an example of an actual MAC address in transit. And it might be hard to see, but on your own machine, when you're in the TryHackMe room, you'll be able to see very clearly where it's highlighted. It says source, and then at the very end in parentheses, it gives you the actual MAC address. And so there's a source MAC address where the message is coming from, and there's a destination MAC address, so where the message actually wants to go. So read through that, check that out, and remember, layer 2, think MAC address, okay? Now on to layer 3, the network layer. When you think of this layer, I want you to think, because I'll just go back. So layer 2 is host to host, or 2 computers on the same network. When you think of layer 3, I want you to think network to network, and I want you to think about routing. That's a big part of layer 3 networking, and being able to get, something from one network to a totally different network through the internet. How does it get there? What's the fastest way? How come it doesn't take forever? There's a bunch of questions around it. I'm not going to get into all the details of exactly how that works and how your computer decides where to route things through the internet. But read through this. Like I said, I want you to think router. And so they give us a nice example here. And you have computer A, computer B. They're on separate networks. So as an example, let's say computer A is you, and let's say computer B is TryHackMe.com. So you're going to send your stuff to your router at your home, and then it has multiple paths that it can go to get to TryHackMe.com and get what you want, which would be the web page for this room. So in that example, the important thing here is all the routing, and that's done using IP addresses, which we'll talk about more later, so I'm not going to talk about them too much right now. But when you think of layer 3, I want you to think routing and IP addresses. Okay. Next is layer 4, the transport layer. And this layer enables end-to-end communication between running applications. So what does that mean? Think of this layer as kind of like the connector. So the IP address is going to get my stuff from computer A to computer B. Once that's done, I consider layer 4 is like, okay, now how are we going to maintain that, and how are we going to do that repeatedly? That's the way I think of layer 4. So that's why it's called the transport layer, because really the network layer is to set the route. That's one way to view it. And the transport layer is to actually get everything there and everything back repeatedly, multiple times. So that's why you can kind of think of it as this end-to-end communication between running applications. And what's important on the transport layer is I want you to think of TCP and UDP. These are two networking protocols. We're not going to talk a lot about them because we'll cover those more in a later task, but think TCP and UDP for layer 4. Then layer 5 is the session layer. And what's important about this is it establishes a session, so it initiates communication, and then it decides how are we going to communicate. So when you think of session layer, that's what I want you to think of. Like, we've opened a session. So back to our example, computer A is now talking to computer B. How do they know how to talk to each other, right? Like, what are the rules of the conversation? And that's all set in kind of this session layer where it decides, it's going to establish it, and it's going to, like it says right here, negotiate the necessary parameters for the session. Another big thing that it does is data synchronization, right? So it makes sure that the data is transmitted correctly and the order is correct. And it provides mechanisms for recovery if transmission fails. So that's the session layer, really important. But again, I like to think of initiating a session and then synchronizing a session. So think of those two things. Then the presentation layer, and what this does is, TryHackMe says it really well right here. This layer handles data encoding, compression, and encryption. That's all I want you to think about for now. If you don't know what those mean, as you move through TryHackMe, you'll learn more about encoding, compression, and encryption and all these different things. You'll learn about the different protocols involved with that and how that works. But for now, just think encoding, compression, and encryption. And they even give you an example here of encoding in characters like ASCII or Unicode. So if you don't know what that is, you can Google it. It should be pretty straightforward. Hopefully you've heard of ASCII before. If not, no worries though, because again, as you move through TryHackMe, you'll learn more and more about these three things. But that's what layer 6 does: encoding, compression, and encryption. And then layer 7, so this is the actual layer that services directly to the end user. That's the way I view it. So this is the layer that actually reaches the user, kind of. That's one way to view it. And this has a bunch of protocols in it. Here's a bunch of them. Hopefully you've heard of some of them, especially HTTP. That's a very common one. So that's layer 7. So now we've kind of gone through the 7 layers. Here's a nice summary. So we have layer 1, physical, And then this is between adjacent nodes, so I want you to think MAC address. And then this is routing and logical addressing, so I want you to think IP address. And then up here, end-to-end communication, UDP and TCP, that's what I want you to think of. Then here, think of establishing and synchronizing. If you also maintaining, you could, like they have in here, would be a good like keyword that you can pair with layer 5. Then layer 6, encoding, encryption, and compression. And then layer 7 is the interface to the actual user or application. So now that we've gone through that, let's answer some questions. Which layer is responsible for connecting one application to another? That would be layer 4. I think there was a space. Yes. And then which layer is responsible for routing packets? That would be layer 3. And then in the OSI model, which layer is responsible for encoding the application data? That would be layer 6. And then which layer is responsible for transferring data between hosts on the same network segment? That'd be layer 2. Ooh. Oh, wait a minute. I needed the space. It's still layer 2. That's the right answer. Okay, with that, we are done with task number 2. Now it's time to move on to task number 3, the TCP IP model. So you can read all this up here, but basically it's going to give you a history about the TCP IP model, and then it's going to explain to you that it's not the OSI model, and this is the actual model that we use. Because the world isn't perfect, and the OSI model is this hypothetical, like ideal how things should be in the world. Not to say that we might not ever get to a point where we do totally use the OSI model as described, but right now we don't. Right now we use this model, which is the TCP IP model. And here they have a little map to the different layers. So in the TCP IP model, you have the link layer, which is the same as layer 2. You have the internet layer, or sometimes people call it the network layer still, and that's the same as layer 3. Then you have the transport layer, which is the same as layer 4. And then the application layer is layers 5, 6, and 7 in the OSI model. And we can see that right here. Now, again, because we don't live in a perfect world and not everybody agrees on everything, some textbooks and some people actually say that the TCP IP model has 5 layers. And it has the physical, link, network, transport, and application. The link, network, transport, and application are the exact same as the ones I just went over here. It's just some people like to include that physical layer in the TCP IP model. So as far as this room goes, we're going to assume this, but don't be surprised if you're ever talking about it and someone brings up the physical layer, which is the same as the physical layer in the OSI model, and they refer to it in the TCP IP model, right? And then just kind of remember this is the OSI model layer, and then this is the TCP IP model layer. So these 3 are all equivalent, and then the application layer does all of those. And sometimes the physical layer is either included or it's not. Just kind of depends on who you're talking to. So make sure you read through all of that, and then we'll answer some questions. Which layer does HTTP belong to in the TCP IP model? That'd be the application. Oh, I didn't even look at the format. Was that? Okay. It's application layer. You have to include layer. So how many layers of the OSI model does the application layer in the TCP IP model cover? So what they're asking here is this TCP IP model application layer, how many layers does it cover in the OSI model? And that would be these 3, the application, presentation, and session. So we'll do 3. Perfect. And with that, we have finished task number 3. Now it's on to task number 4, IP addresses. So IP addresses, what are they? They're unique identifiers that, help us identify things on inter-network. How would you say that? I'm not sure how you'd say that, but from one network to another, they're really important. Now, in addition to that, each device on a network has a unique IP address, but we'll get more into that when we talk about private and public IP addresses. So don't worry about that for now. For now, just think IP address, it's a unique identifier that helps something be found. So if you're a computer on the internet, when I go to TryHackMe.com, how does my computer know where to go? And what my computer does is it converts TryHackMe.com into an IP address, and then I reach out to that IP address. And that IP address is unique to TryHackMe.com. Nobody else has it, right? So that's kind of how that works in very simplified terms. And the way it's formatted is you have 4 what are called octets, and that's why you have these dots and then the 4 chunks of numbers between them. And each one can range from 0 to 255. And it's just a number to identify something. Just think of it that way for now. And then they also make a note that there are a couple IP addresses that are reserved. The network and broadcast addresses, respectively, are reserved. So in this case up here, we're going to copy this exact one. So why did they put 0.1 instead of 0.0? Because that is the network address. And then 255 is the broadcast address. Okay. So those two are always kind of reserved. And you'll see that as you go through TryHackMe and gain a bit more experience that, you know, normal devices won't have those IP addresses because they are reserved. So they're the minimum, like the lowest IP address, and then the highest IP address. So you kind of have to subtract those two when you're figuring out how many IP addresses there are. So, yeah. And we won't talk about right now what a broadcast address or network address is. You'll get into that more in later sections of TryHackMe. So now they're going to show us how to look up our network configuration. So they give us some examples here. We have depending on what you're on, ipconfig, ifconfig. Read through all that. I'm not going to get too into it because hopefully you have a basic understanding of Linux and Windows command line. So that should be pretty straightforward, but we will look at the output. In the output, if we look here, we have the IP address of the host. We have the net mask, or the subnet mask, and then we have the broadcast address. Remember that .255? So that one's reserved for the broadcast address, and we can see it right here. And then they give you a little explanation down there, and then they give you additional output just to see how it compares. And we can see there's the IP address again, here's the broadcasting address, and here you don't see subnet mask. Instead, it has this -24. And they explain that right here, and that means the leftmost 24 bits within the IP address never change across this network. If that doesn't make sense to you, you should check out the pre-security pathway or just Google it. I'm not going to get into subnetting and subnet masks in this video or in this room, because that's not what this room is about. So just read through it. Hopefully you understand it. And hopefully on your own computer, you can find your host address, your broadcast address, and if you need it, your net mask. Should be pretty straightforward. So read through all that. And then this is where we get into private addressing. So you have public IP addresses and private IP addresses. So like I said, IP addresses are unique identifiers to identify a host. Now, where this gets a little tricky is that when the internet was all first created, that was fine, and every computer got its own IP address, which was great. But then we started running out of IP addresses. So we created this thing, network address translation. I think they might talk about it later in this room. And if not in this room, they will talk about it in one of the other rooms. But basically what you need to know is to make everything work, they had to split IP addresses into public IP addresses and private IP addresses. And now the way that I like to think of it is your public IP address is like your home address. It is unique to you. Nobody else has your public IP address, because the whole world, if we want to be able to identify something specific somewhere on the other side of the world, it has to be unique. So every public IP address is unique. Only one place has it. Now, private IP addresses are unique within a network, but they are not unique between networks. So let me give you an example, and I'll use like a home network, let's say. So do they have a good image for this? Not really. Okay, I'll use the example anyways. So at your house, you have your computer. Your computer has a private IP address. Now, if you go onto your neighbor's Wi-Fi, there's a good chance that their computer has the same private IP address as yours. Okay, so now you're thinking, well, that's not unique. How is somebody going to find me? Well, the way that they find you is your computer might have a private IP address, but your computer network, so your home Wi-Fi, has a unique public IP address, and it's the only one that has that. So your computer, your phone, your laptop, your TV, they all have private IP addresses inside of your network, but your network as a whole has one public IP address. And so if you want to communicate with your neighbor through, or send a message to your neighbor through the internet, then you will go from your private IP address on your computer, you'll send that to your router, and then your router will use its public IP address and go to your neighbor's router, and then from their router to their device. So it's a little convoluted. Again, we'll get more into it when we talk about network address translation, but hopefully that made sense somewhat. So that's how it works. So any network has a public IP address, but individual devices may have a private IP address. That's not always true. You could have a device and get it its own public IP address, although that's not common, especially if you're like, in a regular home or office or something. So keep that in mind. And then here they're going to tell us what the private IP addresses are, and they recommend that we memorize these. I'll be honest, I don't know that I couldn't recite them, but a lot of times I can recognize them upon seeing them, just because I've done it enough that eventually you catch the patterns. Like if anything starts with a 10, no good. If it starts with a 172, now there's a .16 to .31, but generally if you see 172, for the most part, my brain immediately starts thinking, well, maybe that's private. And then same thing with 192, 168, anything in that range is also going to be a private IP address. So make sure you probably should just memorize these. I'm reluctant to say that because it took me a long time to do that and I put it off, but you should probably just do it. So memorize the private IP addresses so that you can recognize what's private and what's public. And then the next thing they want to talk about is routing. So routers, they're super cool. They give you a nice example here comparing them to your local post office. And you at home, you have a router, and that router is in charge of getting things on the internet where they need to go. So routing, we kind of talked about it before. That'll happen on layer 3, and what it's going to do is it's going to take a look at the IP address of whatever's being sent, and it's going to use that IP address to then determine where it needs to go, and it'll go one hop at a time. So if you're here and that's your router on your home network, so it's going to determine the first hop. That's all it's going to do, is it's going to say, okay, well, what's hop 1? And then let's say it picks this router, it's going to go there, and then this router will do the same thing. What's the next hop? And until you eventually get to whatever content you're trying to reach. So layer 3, IP addressing and routers are basically like the postal system, helping things get where they need to go. So now that we've gone over that, we'll answer some of these questions. So which of the following IP addresses is not a private IP address? So again, we can tell because it starts out with this 49, which is not in any of the private IP address ranges. And then which of the following IP addresses is not a valid IP address? So a common one that they do here is anything outside of 255 is not going to be a valid IP address. So, and we can tell because that one has 305 in it, so mark that. And with that, we're finished with task number 4. Now it's on to task number 5, UDP and TCP. Okay, so once you've gone through the IP protocol, that allows you to actually reach where you want to go. The next thing you need is you need to decide how you're going to communicate with each other. How is that communication going to be processed? And there's two ways to do it. You can use UDP and you can use TCP. And I like to think of just an example that I always use because it makes the most sense to me is think of UDP as one person and TCP as another person. So have you ever met that person that when you're having a conversation with them, they just talk at you and they don't stop, and it's repetitive, it's one after the other, they just keep talking at you, and you have no room to say anything, and information is just being flooded at you. If you don't understand something, they're not going to stop to explain it. You don't have time to ask them what something was, or if you misheard them, you can't say, "What'd you say?" because they're just talking so fast. That's UDP. That's how UDP works. UDP is a protocol that doesn't care if the destination is receiving the messages. It doesn't care if a packet gets lost. UDP is just focused on sending everything we can to where it needs to go as fast as possible. So why would that be a thing? That's a thing because of stuff like FaceTime or streaming, right? When you're streaming or FaceTiming, you're sending tons of data at a very rapid pace. And if you took the time to confirm, hey, did you get this? Does this all make sense to you? Is anything missing? Then streaming wouldn't work. It would be all broken up. It'd be pixelated. You'd miss parts of what people are saying. It just wouldn't work. So when you're streaming or using FaceTime, something like that, you're going to be using UDP because it just sends out the information, and chances are 99% of it is going to make it, but sometimes it doesn't. So when you're on FaceTime, sometimes people will freeze up or whatever. That's because packets are being lost, but UDP doesn't care. It's going to keep on going because the person on the other end of the phone is still talking. So that's how UDP works. So think of it as that person that just talks at you and leaves no room for you to ask questions or say anything. Now, TCP is how most normal conversations work. There's a back and forth. There's time for you to say, hey, did you understand what I just said? And for the person receiving it, they can say, hey, I didn't get that. Could you repeat that one more time? A normal conversation. That's how it works. And something that'll come up a lot is this way that TCP establishes a connection. And they establish it by sending a SYN, SYNAC, and then an ACK, right? So you as the person wanting to start the connection send the SYN, which you can think of as being like, hey, are you there? And then the SYN ACK, which stands for acknowledgement, that ACK at the end, they're going to respond and they're going to say, yeah, I'm here. And then you're going to say, great, I hear you, right? Something like that. So that's the way you can think of it, is it's this nice back and forth to confirm, hey, can you hear me? I'm talking to you. We're all on the same page. Great. And then after this ACK, that's when real data transmission starts. And then you start, sending stuff back and forth. And so TCP is, again, more like a normal conversation. You can read through all this. Make sure you read everything for UDP as well. TCP is going to be more reliable. So that's used for things like when you're trying to connect to TryHackMe, for example. If part of a web page is missing, or if one of these tasks didn't load properly, then you can't really move on. You can't go through the room. So TCP gives you the opportunity, like I said, to check and say, hey, wait, I didn't get that. Can you send me that one more time? So TCP is better for that kind of stuff. Let's see. Yeah. And one of the ways that TCP makes sure that we're getting everything and everything's understood is you have a sequence number that's sent with each one of these. And this makes it easy for somebody to identify a lost or duplicate packet. And then we can respond and say, hey, I don't have this packet because we're off by one number. Can you send it to me again? So yeah. Read through all that, but again, just think of it. TCP is more like a normal conversation, and you're going to want to memorize this SYN, SYNAC, ACK. It's called the three-way handshake. People talk about it a lot. You'll want to know that. So TCP, normal conversation. UDP is that person that talks at you. So remember that, and then we'll go down here and answer the questions. Which protocol requires a three-way handshake? That would be TCP. And then what's the approximate number of port numbers in thousands? So I know this one off the top of my head. That's 65,000. They talk about ports right here, so make sure you read it. We're not going to worry too much about ports, but ports are what different services are hosted on. So TCP uses one port, UDP uses another port. That's kind of one way to think about it. Or a better example is like, let's see if I can find it. Back up here. Here we go. So see all these protocols? We have HTTP, FTP, DNS, POP3, and you don't have to know what all these mean, but IP, ICMP, IPsec. So a lot of these are protocols, and each protocol kind of gets its own default port, and that's just something that you'll come to understand as you keep going through this. Again, this section isn't really about ports, it's about UDP and TCP, but just know that there's a lot of ports and each thing gets its own port. So each protocol has its own port. So just remember those two things and you're good. So with that, we're done with task number 5. Now it's on to task number 6, encapsulation. So encapsulation. So how does this actually kind of work in practice? And they give us a nice example here from the application data layer all the way down to the data link frame, or the application layer to the data link layer. Oops, didn't mean to click that. And so basically we'll just run through this example. What it starts with is we're going to start with the application data, and the application data is what you write. So let's say you want to send an email or write in a message to somebody. That's the application data. So the first thing that's going to happen is that's going to be passed to the transport protocol, or transport layer. And what it's going to do is it's going to put a TCP UDP header. And that slash means TCP or UDP, depending on which one you're using, right? So if you want to send a message or an email, chances are that's going to be a TCP header, and it's going to add that on to this application data. Okay, so after you add this TCP or UDP header to the application data, then it'll get passed down to the network layer, and this network layer is going to add an IP header, which we can see right there. And so now you have IP header, TCP or UDP header, application data, and then finally that goes down to the data link layer, and that's going to give you either an Ethernet or a Wi-Fi header, depending on which one you're using, and it's going to cap it at both the front and the end. And then this is what's going to get sent. And then when someone receives all of this, they're going to reverse that process. So first they're going to look at the Ethernet Wi-Fi header, then they're going to get rid of it, then they're going to look at the IP header, get rid of it, TCP or UDP header, get rid of it, and then at the end, the person receiving it will just have the application data. So that process of taking the application data, encapsulating it, and decapsulating it, that's how communication works, and we kind of call all of that encapsulation. So it's something that you'll have to know. And the other thing that they want you to know is that in each of these steps, the data is given a different name. So in this first step, in the application layer, when there's nothing else there, that's just called application data or data. Then once you add the TCP UDP header, that's then called a segment or a datagram. And that depends on whether you're using TCP, it's called a segment, or if you're using UDP, it's called a datagram. Then you're going to add the IP header, and that's in the network layer. And once you do that, it's now become a network packet. And then once you add the Ethernet or Wi-Fi header, it's now a frame. So we refer to the data in different ways as it moves up and down this process. So that's important to know. Then down here, they give you an example where they go through it step by step, kind of the life of a packet. A lot of times you'll just refer to, sometimes people will just say packet for a lot of these, but they do technically all have different names for each different step if you wish to specify. So read through all this, and then one thing that might seem semi-confusing is the router is going to remove the link layer, after you read through all this, inspect the IP destination and then route the packet to the proper link. So what it's going to do is it's going to remove the link layer, decide where it needs to go, add the link layer, and send it. And so this link layer is going to get taken on and off for every single step it takes in the routing process. So don't worry too much about that. That's not too important, but it's good to know. Don't let it confuse you. This is still a great example, so read through it. It kind of goes what we talked about over here, but gives you a real world example where you're trying to get to the TryHackMe, where you're trying to find a room on the TryHackMe search page. So read through all that, and hopefully you have a better understanding of encapsulation. And then on a Wi-Fi, or now we're down to the questions, and it says on a Wi-Fi, within what will an IP packet be encapsulated? That would be a frame, because we're talking about Wi-Fi, so that's this link layer. And then what do you call a UDP data unit that encapsulates the application data? That's a datagram. And then what do you call the data unit that encapsulates the application data sent over TCP? That's a segment. Okay, and we went over those right up here: segment, packet, frame. So hopefully that makes sense, and datagram. So with that, we're done with task number 6. Now it's on to task number 7, telnet. So I've already started my machine, and now I'm in split view, and somebody asked me how I did this, so I'm gonna kind of walk through it. Right here, you can hit the full screen button. That'll open it up in a new tab, and then you can go back and you can hit this exit split view button or minimize button, and now you have your machine in a new tab, which is nice. So I can't remember who it was that asked me that, but somebody asked me how that works, so I wanted to demonstrate it for them here in this video. Okay, so now we're on to task 7. We have our machines all set up. We're in the terminal, and what they're going to want us to do is they're going to want us to use telnet. Now, telnet is a networking protocol that allows you to connect and communicate and through text, and you can connect to any server listening on a TCP port number. Okay, so that's important to know. And there's lots of different types of servers and things that can be running. They give us 3 examples here. We have an echo server on port 7, a daytime server on port 13, and a web server on port 80, which is the default port for web servers. That's important to know as well. So yeah, read through that. You can see what each one does, and then what they want us to do is they want us to connect to each one. So we're going to do that first. I'm going to copy that IP address, and I believe the first one they wanted us to do was on 7. And 7 is just going to echo everything that we type. So hi, it says hi. I say what's up. It's just going to respond with what's up. Then to get out, I do control and then the end of a bracket, and that's the escape character. Oh, nope, don't want that. The escape character is given to you right there. And then you're at telnet. You're in your telnet prompt. So you can just type quit, and now you're out. So that was an example of the echo server, which is just, as it says right down here, is going to echo everything we say. Now we can check out the daytime server on port 13. So all you have to do is change that from port 7 to port 13, and it gives us the date, and then it automatically just kicks us out after giving us that date. So that's pretty cool. And then the last one, we're going to jump onto this HTTP server and see what's going on. So they have their examples here. Read through them if you felt like I moved a little too fast. And now here's what we have to do for actually getting on a web server. So when we connect, we have to give it the command get, and then HTTP 1.1. This, we're establishing that we want to get a web page. We're establishing the protocol that we're using, or the version of HTTP, and then we have to provide it with the host, which is going to be telnet.thm, and then you have to press enter twice. Why do you have to press enter twice? Because in these requests, the last line has to be left blank. So that's why you have to do that. So we're gonna give that a try. I wonder if I can just paste this whole thing in. Let's find out. So we're gonna go up, and to get to the last command I just did, I'm just hitting the up arrow, FYI, in case anybody didn't know that. So hit the up arrow, change the number from 13 to 80, and then it gives us this, and let me see if I can paste that whole thing. Yeah, I can. Oh wait, nope, it says bad request. Now, why does it say bad request? I'll tell you why. Because I can't highlight this space. If I could highlight that space, then it would be a good request. So here's what I'll do. I'll do the same thing, and this time I'll just type it. So it's going to be get HTTP, and then that's 1.1, and then hit enter, and then we'll want the host, which is going to be telnet.thm, and then you have to hit enter twice. So enter, enter. It still says bad request. Why is it doing that? Oh, you know what? I didn't put a space between host and telnet. There you go. So sometimes this is just, how things work. You gotta really put in the effort. So HTTP 1.1, make sure I have this all right, and then we're gonna do host, put the space, telnet.thm, enter, enter. Why am I still getting a bad request? I must be missing something. HTTP /. Oh, I forgot the /. Geez, this is a great example of what not to do and to pay more attention when you're typing something in. Wait, see, I don't even remember. Okay, so I'm putting this / in the wrong stinking place. Most of the time in the real world, you have stuff that does this for you. So not very often are you using telnet to communicate directly with something. So 2 enters, there we go. It finally worked. At least you got to see me struggle through that. So if you're having problems, don't worry about it. You're probably just missing a detail. So just review and pay attention better than I did. So here we have a flag. We're probably going to need that. So I'm going to copy that. And then we'll go down here. What is the name version of the HTTP server? Well, first I'll put in this. What flag did you get? So we got in this flag, so we can submit that. And then it wants to know the server version that we got, and that's right here. This LIG HTTPD 1.4.63. So copy that and then paste it in there. Hit submit, and then with that you are done with task 7, which gave you a quick intro to telnet, kind of how to use it. And again, pay attention, be better than me, and make sure you type that in right the first time, not the 3rd time or 4th time. And with that, we're done with task 7. Now it's on to task 8, the conclusion. So basically this room went over, like it says at the top, some networking concepts and some essential ones that we need to know. And we'll get more into detail about the really important ones as we move through this networking module. The next room they want you to do is networking essentials. So check that out. I have a video of that on my channel, so you can check that out there for a full walkthrough. So hopefully this video was helpful. If you liked it, give it a like and subscribe. That helps me out a lot. And with that, we're done with task number 8, and we're done with the networking concepts room from TryHackMe.